In this video, I'd like to give you a brief overview of the history of the so-called replication crisis in the biomedical and life sciences, and talk briefly about the emergence of open research practices, which may be one way in which to improve how people do science. So first of all, we're going to start by jumping into my time machine. And we're going to go all the way back to 2011, where a paper was published which seemed to prove the existence of extrasensory perception. So this paper by Daryl Bem generated a lot of media coverage, a lot of social media commentary as well. The paper was published in the Journal of Personality and Social Psychology, and it seemed to provide strong evidence that the future can influence the present. The paper consisted of a number of studies, and in one of those studies, using an absolutely standard priming paradigm, participants responded faster to target words that were then followed by a prime word than to targets that weren't followed by a prime word. So in other words, people's response times to an item were influenced by what came next. Okay, so this is quite remarkable. And Daryl Bem, he's got a distinguished track record. He's a very well respected scientist. The paper came out in a top-tier journal, Journal of Personality and Social Psychology. It's a very good journal. It went through standard, rigorous peer review, and it used standard statistical and scientific methods, which basically meant that science appeared to be broken. So this caused a lot of academics to try and figure out where things were going wrong in terms of the typical way in which research is conducted. This great paper by Simmons, Nelson and Simonsohn showed that by selectively reporting data, in other words doing things such as dropping certain participants, excluding so-called problematic trials, not reporting all of your analyses, perhaps only reporting the analyses that were statistically significant. Well, if you do all of these things, what you end up with is a vastly inflated false positive rate. This was later termed p-hacking. And I guess it's worth pointing out that, dropping participants, excluding trials that look a little weird, reporting not all of your analyses are, fairly common practices in psychology. So this caused a little bit of concern over, what else out there in the literature might actually, be wrong. I guess the Daryl Bem paper was really looked at in a lot of detail because it seemed to just go against everything we know about how physics works. But what about all those papers out there in the literature, that maybe haven't been read by a huge number of people that might also be wrong? So Nosek set up a series of replication studies to try to determine how big this replication issue might be for psychology. This resulted in the establishment of the Centre for Open Science in 2013. So some of you might recognise these three individuals here, all standing in a particular way. And if you're of a certain age, such as I am, when you look at an image like this, what you're probably reminded of is Blackadder, with this sort of very unusual stance of Hugh Laurie as the Prince Regent. So this is an example of power posing. Power posing, the paper came out in 2010, and it claimed that if you stand in a certain way, not only do you feel more powerful, but you actually become more powerful as well. So again, this paper came out in a great journal, Psychological Science, and it seemed to suggest that there were basic physiological changes that came about within your body as a result of how you held yourself. So this was another paper at the time that kind of caused a lot of media chatter, and it was almost again part of this general set of questions about, well, how much of what's published can we actually trust. So in 2015, a project was set up to estimate the reproducibility of psychological science, where 270 authors tried to replicate 100 different experiments drawn from top-tier psychology journals, Psych Science, JPSP, JP, LMC. And what they found was out of those 100 experiments, 61 didn't replicate. Only 39 replicated. And in many cases, even when a study replicated, the effect size of the replication was actually much smaller than the effect size reported in the original paper. So in the context of power posing, a lot changed between 2010 and 2016. It used to be thought that, as I said, if you act powerfully, you will begin to think powerfully. So the way in which you stand affects your sort of body's physiology. But it didn't replicate. I mean, I think it's quite clear that this was an unlikely effect because it wasn't clear what the mechanism might be. There was, result in physiological changes as a function of how you stand. And even one of the report's original authors says, actually, it was all nonsense. Dana Carney says, I do not believe that power pose effects are real. Standing like John Wayne in a gunfight does not make you feel like a successful gunslinger. It just makes you look silly. But despite this, many organizations at the time were bringing in consultants to teach members of that organization how to stand. So it was a very lucrative endeavor that emerged from this one flawed paper. And actually many replications have failed, or the reported effect sizes are much smaller than in the original. So power posing, I've mentioned, there's cases such as ego depletion, social priming, learning style, Stanford prison experiment, it was never really an experiment, growth mindset have all been looked at much more closely and either haven't replicated or have replicated but with much smaller effect sizes. And it turns out none of this is new. These problems people have known about for a while. Going all the way back to 1967, Paul Meehl really highlighted this issue as something that people needed to address. He talked about a liberal use of ad hoc explanations for effects that didn't pan out. So really much, doing an experiment and then trying to make sense of it after you've got the results, or the results haven't been those that perhaps you expected. And again, a little bit more recently, Doug Altman in 1994 said, well, actually, the problem is that the system encourages poor research, and it's the system that should be changed. In academia, people are published in journal articles and tend to be evaluated on the basis of things such as the number of publications. But this doesn't necessarily lead to a better research literature at all. It just means we've got a bigger research literature full of many papers that probably report effects that aren't real. So Doug Altman said we need less research, better research, and research done for the right reasons. And abandoning using the number of publications as a measure of ability would be a good start. Norbert Kerr coined this wonderful word, HARKing, hypothesizing after the results are known. So this is what happens, when you'll set up a study to test some predictions. The results of the study are significant, but don't really, say anything about, the predictions maybe that you set out to test. But there's a significant pattern of results there. And being a clever academic, you'll go, oh, I wonder what's going on here. And you'll have a bit of a think, and you'll come up with a really nice, clear explanation as to what your results actually mean. But what you're doing there is you're hypothesizing after the results are known, and may well be creating a story that's just entirely fiction. Maybe your results are simply false positives, and by trying to sort of make sense of them and build a theory around them, you're really building a theory on non-existent foundations. I guess most recently, this paper by John Ioannidis in 2005 really kick-started the current conversation around reproducibility and issues around replication, where he claimed that most published research findings are false. And what seems to be the case is that it's not just that there's good science and bad science out there. It seems to be the case that without realizing it, many good scientists have been engaging in what are known as questionable research practices, QRPs. And this is partly driven by an incentive structure that actually doesn't incentivize good scientific practice. This great paper by Mark Sminafu and colleagues really highlights all those different points in the research process where problems emerge in terms of how people conduct their research, or problems, i.e. questionable research practices, that when you consider them all together result in a literature that's full of papers that can't be replicated. Low statistical power is an issue, not having enough observations in your data set to build the kind of statistical models that you want to. P-hacking we've talked about already in terms of sort of the way in which you analyze your data, maybe not reporting all of the analyses, selective reporting, selective interpretation, a huge problem of publication bias in the literature, in the sense that what tends to get published are results that are significant. You never hear about all those experiments or papers that failed to find an effect. So taking all of these things together arguably results in the situation that psychology and science was in a few years ago. So why do so many studies not replicate? So we talked a little bit about low experimental power, with studies being underpowered for the effect size of interest. And one of the consequences of a low-powered study is that when real effects are actually detected, the magnitude of the effect size is likely to be overestimated. Studies which find the effect are published, studies that don't are not published. So you end up with this publication bias. And one of the issues around this is if you're doing any sort of power analysis or data simulation for a study that you want to run yourself, you might actually base your expected effect sizes on the literature. But if the literature itself is wrong or overestimates those effect sizes, then you'll end up also running an underpowered study, and the problems then sort of continue. So experimental power is an issue right across the board for many areas of science. A couple of great papers, Button et al. And Nord et al. Looked at the issue of power, and across a number of aspects of neuroscience, it was quite clear that many studies are underpowered. So if you look at the table, you'll see psychology has a median power of about 50%. So 50% of the time, these studies are going to find the effect they're looking for. Genetics, that's a bit scary, just 11% median power. So for a study with 11% power, run that study, even though the effect is there to be found, only 11% of the time will it actually be found. And this is a huge waste of time and money, running studies that are unlikely to find the effect even though it's present. I completely recommend this sort of letter by Dorothy Bishop, came out in Nature, where Dorothy reflects on what's happened since the John Ioannidis paper came out, and looks back on sort of all these other people that had raised issues and warnings about replication and reproducibility in psychology. And I really like this quote that's lifted from this letter. Many researchers persist in working in a way almost guaranteed not to deliver meaningful results. And why would you do that? Okay, why would you do that? Such a waste of money and time. So, how do we make our science more reproducible? This is, an issue that's led to a number of organisations emerging, joining forces. And within the UK, the most high-profile one is the UK Reproducibility Network, set up by Mark Sminafu and colleagues in sort of 2018-2019. very much focused on a grassroots initiative to bring academics together to coordinate and engage with key stakeholders in order to make science better. So it's a peer-led consortium, and it works by investigating the factors that contribute to robust research, will provide training and disseminate best practice, working with stakeholders to ensure coordination of efforts across the sector. Led by Marcus Manafu, Chris Chambers, Laura Fortunato, Alexandra Collins, and Malcolm MacLeod. So in addition to the UKRN, there are a number of other organisations that are kind of linked with the UK Reproducibility Network. One of the ones that you might have come across previously is a fantastic initiative called ReproducibiliTea. It's aimed really for helping younger researchers, creating journal clubs at the universities to discuss a whole bunch of issues around open science, open research, reproducibility. It started only in 2018 at the University of Oxford, but now exists actually in more than 81 institutions in 22 different countries. There could well be a reproducibility journal club at your university. If there isn't one, you might want to consider starting one. They're very easy to set up, and it's a great global network to be part of, especially if you're an early career researcher. So you can kind of see in the map there just kind of what the spread is of ReproTea journal clubs. So there's the parent organisation run by a group of early career volunteers. I recommend that you follow them all on Twitter. Lots of great stuff posted about these journal clubs. Many of them have been running online during the summer of 2020. And there's even a podcast that you can subscribe to as well. So in addition to kind of the grassroots initiatives that the UKRN has been encouraging, the UKRN has also asked universities to appoint institutional academic leads for research integrity at their home institutions. And the idea is that these institutional leads will ensure that there is appropriate training around research improvement and the research culture more broadly, the promotion of the adoption of open research practices in job advertisements, promotion criteria, and embedding the ways in which you do open and reproducible research within the institutional culture. So it's great to see universities at an institutional level now signing up and appointing these leads. So in addition to the institutional leads, a number of universities have open research working groups. There are currently, I think, more than 57 now, actually, within the UK. These are grassroots-led organisations. The idea is that they should cross academic disciplines. It's not always easy to do that because of the way universities tend to be structured. We have one at Manchester that I co-lead along with Caroline J in computer science, and we sort of bring academics in from basically every faculty actually at Manchester. So it's a matter of sort of building those kind of cross-faculty connections and perhaps linking in with other groupings at your university that will probably be interested in these kinds of initiatives. And it's also important to note that this isn't just for research-focused institutions. There are actually many traditionally teaching-focused institutions who have engaged with UKRN, who've got their own very active open research working groups, because obviously we need to teach the next generation of scientists about these open research and reproducible practices. And it's really important that everybody, regardless of their teaching research balance, regardless of their career stage, is part of the conversation. It's not just about how we do better research, it's also about how we teach our students how to do better research. You can build a regional hub of open research working groups. This image, courtesy of Dermot at Lancaster. We had an event at Manchester in February 2020 where we brought together a number of local open research working groups. where early career academics came together, met sort of people from lots of different backgrounds, lots of different universities, to talk about and present issues centered on open research and reproducibility. So you can click on this link at the bottom of this slide. It'll take you to the document that emerged from our Beware Results May Vary event, Openness as a Way of Enhancing Research Quality, where we had a number of fantastic talks, early career researchers, mid-career researchers, established leaders in the field, and a fantastic keynote talk from Dorothy Bishop. So you can really want to think about this in terms of connecting communities within your own institutions, but also within your regions, and bringing together other organisations that you may be affiliated with, who are probably all concerned about the same kinds of things. So we've got the ReproducibiliTea journal clubs we've talked about, UK Rein. There are various sort of R groups all across the world that, obviously R is critical, and software like R is critical for doing open and reproducible research. The Carpentries, the Software Sustainability Institute, great organisation. I'm a fellow of the SSI, very much focused on reproducibility, open license scheme, and at Manchester, the reproducibiliTea Manchester group. If you haven't come across it before, I also recommend you check out the Turing Way. It's a fantastic handbook for how you do reproducible data science. So, this is a whole bunch of communities, a network of communities that at their core are concerned about doing research in a better and more reproducible manner. But it's important that institutions get on board. They're starting to. Institutions really need to support researchers who are wanting to adopt open research practices in their own workflows. There are a number of things that have to happen, really, for that to really sort of gain traction. The academic incentive structure has to change, so people should be rewarded for doing good research. There should be less focus and reward for people who are doing expensive science, and more focus and reward for people who are doing better science. Within the UK, the Research Excellence Framework could play a role in encouraging universities to do this. And it's nice to see that within the context of psychology, psychiatry, and neuroscience, it's starting to do that. And one thing that's really struck me over the last year or so is that across disciplines and institutions, there can actually be a surprising lack of understanding about what open and reproducible research actually is and what it isn't. In many cases, you'll mention open research to somebody, and they'll think you just mean open access publications. So there's real confusion or lack of understanding about the broad range of activities that are covered by the open research umbrella. And I think the biggest challenge, many times I talk to academics who want to do better research, they want to adopt open and reproducible practices, but actually they don't have the coding or computational skills to be easily able to do that. So we really need to be teaching these kind of skills to our students, who are the next generation of researchers, obviously, because it's apparent that there's a huge computational skills gap amongst not just PhD students, but also postdocs and teaching stroke research academics, where generally speaking, these researchers don't have the experience in coding to be able to use software such as R or Python or other tools or other computational infrastructures that are absolutely critical for them to engage in open and reproducible science. And without these skills, they simply can't adopt open and reproducible research practices. So that's something I think really needs to be addressed because it is an issue.